everybody's favorite, rectangles. Well, first thing about rectangles, we just got done with parallelograms. Well, all rectangles are parallelograms. And why is that? Well, that should be necessary. Opposite sides are parallel and congruent. So if I look at a rectangle, I have opposite sides that are parallel and opposite sides that are congruent. Okay, so that works. Opposite angles are congruent. Yep, these work here. And diagonals bisect each other. They would here as well. Okay, so everything works for rectangles. That works for parallelograms. The only difference is in a rectangle is that all four angles are right angles. So this is the only difference right here that makes it a rectangle compared to a parallelogram. Otherwise, everything else is the same. Everything else is the same if you look at those properties. We got a theorem that goes with it. If a parallelogram is a rectangle, then its diagonals are congruent. So if I draw my diagonals here, AC, going right here, and DB, I know they bisect each other, so I know that each little piece is congruent to the other. But now I also know that they are congruent. So if it's a rectangle, my diagonals are congruent. They would be the exact same length. That's not the case in a parallelogram that isn't a rectangle. But if it's a rectangle, if it has 90 degrees, then it works. So let's use some of this information here. Quadrilateral JKLM is a rectangle. If JP is 3y minus 5, so JP is this piece right here. It's 3y minus 5. And MK is 5y plus 1. Well, that's this whole thing. That's 5y plus 1. Find y. Well, I know that JL all the way to that entire diagonal is the same as MK. But I wasn't given the whole thing. I wasn't given JL. I was just given JP. Well, if I think about it, this is the same as that, isn't it? Because the diagonals bisect each other. So isn't this piece also a 3y minus 5? Which makes the entire length. So that makes this entire guy, those two put together, right? So 3y minus 5 plus another 3y minus 5, or just two of them. 2 times 3y minus 5. So that would be JL. Equals that. So JL is what? Let's simplify that. 6y minus 10. And what I just say, JL is the same as MK. So I can set that 6y minus 10 equal to 5y plus 1. Because the diagonals are congruent. And then we just go through, we get our y's to one side. And bring my 10 over to the other side. So we got y equals 11. Y equals 11. And there you go. That's all I was asking for. So sometimes you just have to think about it a little bit. Don't just set them equal to each other right away, right? Because I had to take 3y minus 5 and another 3y minus 5. So you have to think about it a little bit at times. Well, I also have the converse of our theorem. So basically, if I have a parallelogram, but I don't know it's a rectangle yet, and I state that AC is congruent to BD, then I can state that ABCD is a rectangle. So if I show that those two guys are congruent, I know it's a rectangle. All right, let's keep looking at some more problems that we might run into here. So we got a quadrilateral, it's a rectangle. If measure of RTU, let's figure out where that's at. RTU, so this guy is 8x plus 4. And the measure of SUR, so which is this guy, is 3x minus 2. Find x. Oh boy. Well, can I set these equal? Will they add up to something? What do you think? Well, it's a rectangle, right? So I know that I have all right angles, so I know that I got 90 degrees everywhere, right? 90 degrees in all my corners of the rectangle. What else do we know here? So 90 degrees. Well, I know that diagonals break it up into two triangles, don't they? So I really have a triangle right here. And then I have another triangle right here. Does that help me out at all? I'm not sure if that's going to help me out too much. Well, let's bring another triangle to play. What if I looked at this angle that's up by the red angle, like if I looked at this angle? Let me draw on that triangle over here. Well, wouldn't the blue triangle and the green triangle be the same? Because they share this side, right? And then we know the diagonals are congruent. So the green diagonal and the blue diagonal are congruent. And then we also know that the opposite sides are congruent. So it's by side, 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 these triangles are congruent. Well, so these two angles right here, angle STR and angle SUR are the same. And these two up here make a 90-degree angle. So that 8x plus 4 and that 3x minus 2, those would be complementary, right? Wouldn't they add up to 90? If you take a look at that, because these blue angles are the same, aren't they? And I know that this blue one up here with this red one add up to 90. That means I can set that 8x plus 4 plus 3x minus 2 equal to 90. And most of you can see that without really thinking too much about it. Just by looking, they look like they'd be the same angle. But I just wanted to prove it there by putting in my triangle. So now we just go ahead and simplify. So combine my x's, and 4 minus 2 is a plus 2. And we solve. So minus 2 looks like 11x equals 88, which gives us 8. There we go. So it just takes a little bit of thinking, just looking at it. How about this one? Quadrilateral JKLM has vertices of the following. Determine whether it is a rectangle. Let's graph it first so we can take a look. So I got J at -2, 3. I got K at 1, 4. I have L at 3, -2. And I got M at 0, -3. Let's add an angle. All right, it looks like it should be. How could I test this? How could I test to see if it's a rectangle? Well, we'd have to go back to our properties. What do we know about rectangles? Well, it's a parallelogram. I know it's a parallelogram. So if I could prove this is a parallelogram that has what? One angle that's 90 degrees. One angle equals 90 degrees. If I can have a parallelogram and one angle being 90 degrees, then I know it's a rectangle. So first of all, how do I show that I have a 90-degree angle? Well, I'd have to show slopes. Don't I have to bring slopes into play? So my JK right here, if I could find the slope of JK, and I can find the slope of, for example, KL, if I could show they make a 90-degree angle right here, I know it's a rectangle. So the slope of KL, because slopes are opposite reciprocals, correct? Well, let's find the slope of KL. Down 1, 2, 3, 4, 5, 6. Down 6. Right 1, 2. Which is really -3. So let's see what JK is. See if it's a positive 1/3. Up 1, right 1, 2, 3. Positive 1/3. So there's a 90-degree angle. I just proved that it was 90 degrees with my slopes. So there's part of it. Well, how can I prove that it's a parallelogram? A lot of different ways. I could show that opposite sides are parallel. I could show that opposite sides are congruent. I could show that opposite angles are congruent. Well, since I already found slopes, I'm going to go ahead and write these down. The slope of JK is 1/3. The slope of KL is -3. I bet if I just found all the slopes, that might be the easiest, because then it proves, right here, this proved that I have a 90-degree angle, right? And then if I have the opposite sides, so for example, JK and what, ML are opposite sides. If I found the slope of ML, which is what, up 1, right 1, 2, 3, up 1, right 3, so those are congruent. That's good. And if I found the opposite side of KL, not KL, I already did KL. Find the slope of JM. and see if it's the same as KL. Down 1, 2, 3, 4, 5, 6, right 2. So down 6, right 2 equals -3. So there we go. I just proved it. Because I had opposite sides are parallel. They have the same slope. And I have a 90-degree angle because of the opposite reciprocal slopes. So that proves that it's a rectangle. So don't just draw it. You have to give me some proof. And so basically, just find your slopes. Find your slopes, and that'll give you proof whether it's a rectangle or not.